Now we have Ryan from Dolby joining us. Ryan, how you doing?
Great, Eric. Great to chat to you as always.
Indeed. And we're going to learn a little bit about the building blocks of the metaverse. So take it away.
Fantastic. Well, thanks for the invite, and great to see a lot of familiar names attending today's presentation. So, with streaming media, obviously, we've been very focused on live and video on demand streaming in our industry, but there's this intersection that's happened over COVID, and it's happening through new forms of content creators who are trying to use 3D game engines to merge the live streaming experience that we have through 2D and web forms and different live streaming services that are out there. So I thought it was worthwhile to kind of maybe introduce the building blocks of the metaverse to the streaming media audience to see where there may be new forms of revenue that you guys can generate and clients that you can work with to bring new ideas into the industry that we all love. So I'm going to focus specifically on the 3D game engines, real-time video, and spatial audio, which are all these building blocks that you need to build a metaverse. So why are we doing this? Why am I talking about the building blocks of the metaverse? Well, it's obvious to us over the last couple of years that human nature needs interactivity and interaction. That interaction leads to engagement, which is what we're all looking for, which is what all major brands and broadcasters are looking for, is engagement with the viewer. It's what content producers and content owners are looking for, right? In trying to monetize the value of the things they're trying to produce. And we're very, very focused on two main things. One is the idea of a virtual concert, and the other is the idea of a virtual stadium that could be used for live sports. And Roger Goodell, who's a commissioner of the NFL, highlighted the fact that the NFL needs to find a way to interact with a much younger audience that has grown up with all these mobile devices and is used to these experimental methods of consuming content. And that remote experience needs to feel real. So to give you just kind of one example of this is, I just did a quick search on virtual concerts, right? And you can see CNN is covering this. Justin Bieber has come out with this, and Variety Magazine did a piece on Justin Bieber's initiative to create these new interactive forms of virtual engagement with the metaverse. ABBA, who knows, ABBA is still relevant, I guess. And they're trying to create these virtual concerts in the metaverse. BTS, which my daughter loves, is they tried to use these 2D video live streaming methods to pull in a virtual fan wall, but they're more interested in creating a deeper form of engagement. And is this the new reality for concerts? The Rolling Stone magazine kind of did a piece on virtual reality and how we can marry live music with these experiences. And I saw this article, which is a great example of kind of where we're at. A lot of the products that we're building right now really aren't up to par with trying to deliver on the promise of true engagement with this interactive content. And, Charlie Puth, not a fan, but this particular concert was rubbish. And this is a super fan of his. It just was very disappointed by the expectation of engaging with one of his favorite artists. So this is really what we're doing. And one of the customers that really was the pioneer that was using Millicast and Dolby IO right at the beginning was a customer named Oz that has done several events with Universal Music. And one in particular they were based in Iceland. And during COVID, they want to bring the whole country of Iceland together, a country of no more than, I think, 300,000 people. And they ended up creating an integration with Snapchat to pull in a virtual Bitmoji, render it inside of Unreal Engine, and live stream that to everyone who was participating. And this is just a very quick preview of what that looked like. And I don't know if you guys can appreciate the music that's here, but these are all people that were able to have a live stream that was delivered to their web browser inside of Snapchat. And they were able to control through haptics, interactivity. They're able to, you can see, shine their light, hold up a flame, dance, and engage with this content that was happening live to bring in the new year in Iceland. So what do we need to enable these kind of experiences? Well, we need three pieces. The first of which is a 3D game engine. Life is in 3D, and we need to emulate that. I think people are tired of these fan walls or 2D fan walls that really don't create a level of interactivity that we're looking for. So there's two main game engines that people are using right now to build the metaverse. One is Unreal Engine, and one is the Unity SDK. There are also a lot of other technologies here. You've probably heard of Roblox, and obviously there's a lot of other game engines out in the market, but primarily we've been working with Unreal Engine. And Unreal Engine was able to actually add WebRTC, a real-time streaming protocol, directly into their SDK that has allowed us to create these plugins to stream out and stream in from a webcam or a professional video feed directly into a 3D universe and render that to a screen. So what this is enabling is the return of the thin client. So I'm old enough to remember the dumb terminals of the 1960s, 70s, and 80s. Not the 60s, but from the 80s, I do remember this. And, you know, all the heavy lifting was happening in some back room, right? And this is what's happening with the Metaverse use case too. Unreal Engine is being run on Amazon EC2 or on Google Cloud Platform or on Microsoft Azure or DigitalOcean or any cloud vendor. They're running an Unreal Engine that's doing the heavy lifting of the processing, but they're having to deliver that real-time video to a thin client device like a mobile phone. The mobile phone doesn't have the processing power to render this and run an Unreal Engine, at least not yet. So we've had this return of a need to deliver real-time media directly to these devices, whether it be a thin client in the mobile browser or the web browser, or any other kind of native SDK and different client devices. So this is what we've enabled with our plugins, is the ability to grab the WebRTC feed, deliver it natively inside of the browser, and vice versa, capture WebRTC in real time and render it inside of Unreal Engine. And those are the two plugins that we're working with at Dolby.io. Here is just like a little quick preview of kind of this integration and what it looks like. This is what we're doing. You can see here, this is Unreal rendering here, and this is the speed at which it's being delivered to WebRTC in the browser. Now, this is running locally, but what we're able to do is actually grab that live stream and then scale that over the public cloud. So the use cases here are endless, right? Virtual concerts. A lot of people are actually doing 3D, like for The Mandalorian as an example, they're using Unreal Engine for a lot of rendering. This allows you to capture video and render it directly inside that 3D engine in real time. So that's just a quick preview of what's going on with the actual functionality and how it looks like, right? And the interactivity and the haptics that you can enable through these game engines. So we need the game engine. We need real-time video. And why do we need real-time video? Well, I know I've got one of my previous colleagues from Wowza on the call, and he'll recognize this slide because it was one that we put together at Wowza many years ago to identify the opportunity for the real-time latency that is needed. RTMP delivery has left this huge gap in the industry to try to get sub-second. And even RTMP wasn't really sub-second. So WebRTC is really the only technology that's positioned in the market now to deliver sub-half second across the public cloud at scale. And why is that? Well, it's an IETF and W3C standard. It's been being a standard of both the internet and the web. All the major web browsers, all the major devices have embraced these standards, and it has become the de facto standard for delivering these real-time experiences. And this native support gives us right out of the box support on over 1 billion devices, everything from a mobile device to a computer to a smart TV to game consoles to Oculus headsets and any other kind of Android OS or iOS device that you can think of, right, with these different SDKs using WebRTC and these different clients. So it's obvious that we need 3D game engines, real-time video, and what's the last experience that we need to really create a believable virtual environment? We need spatial audio. And this is where I am out of my depth because Dolby are the industry leaders in everything as it relates to audio, right? And spatial audio. So my colleague Paul Bosted, who runs product at Dolby.io, did a presentation earlier this year on building RTC at scale. And part of that was, these slides are taken from that presentation. And a lot of what Dolby.io is working on and Dolby is working on is the idea of how do we do spatial audio and render it inside of these virtual experiences. We want to limit the number of people that we hear. We want to limit, have a predictable networking and CPU resources of the device that's being involved. We want to have asymmetric hearing. All these things allow us to create these better experiences by controlling the hearing range and render everyone within a certain distance. So it's believable when someone's approaching you in a 3D game engine, you can hear them approaching you, right, as they come closer and closer. So all these tools are things that we're working on and we have available inside of some of our APIs and SDKs. And the big difference here is that WebRTC natively was a peer-to-peer, and so was the way we were doing audio, where here are multiple people in a video conference. We're going to deliver that all to each listener. But that's not scalable. There exposes the actual security of people's IP addresses. The proxy forwarding model, also isn't necessarily the best model because it's not actually doing the realistic rendering and mixing of those audio sources. So that's the spatial mix that Dolby.io is offering with their technology, is the ability to pull in all these multiple sources and intelligently mix those so that it's a believable experience in a 3D world. So that spatial mixing server is the last piece of the puzzle that you need to create these kind of virtual environments. And also the other things that Dolby adds is, world-leading noise suppression, echo suppression, different audio chains for both voice and music. If you want to go to a virtual concert, what do we do about rendering it and retaining the quality of a potential Dolby Atmos concert? All those things are things we have to take into consideration from source to playback, right? As we try to deliver these experiences over the public web. With the public internet, we don't control every device that's on there. That's what makes it so challenging to really reach and make these experiences believable across these media experiences. So in the time I have left, I wanted to just show a couple of quick examples because there's nothing better than seeing these things in action with customers. So this is a customer of ours in LA called Red Pill VR. And Red Pill started out creating these virtual experiences locally inside of a local network. At the time, it just wasn't possible to scale this over the cloud and have a latency that was able to get down to where you need it to be for it to be believable. But now that's something we've been able to do through the integrations with Unreal Engine. And Red Pill VR is now doing some big virtual concerts now, but a very well-known DJ artist and electronic music artist. Similarly, this isn't just for 3D concerts and 3D stadiums. What about the way we connect to do business? Metaverse is another customer of ours that has done some very large scale events where you can come in, share your webcam camera, and it renders to your avatar, and you can join a sales kickoff meeting or a virtual NAB or a virtual IBC or a virtual Streaming Media West. These are believable 3D experiences that once again use these components, as you can see here, both 3D game engines, real-time video, and spatial audio. And finally, another interesting one is the ability to do real-time education use cases. So this is one of my favorite customers in that space that's doing real-time surgical training using VR headsets. And similarly, they have built these worlds in Unreal Engine, and they have a need to deliver that real-time video to surgeons across the world who can then take over the live surgery and through the haptics experience, be able to control these devices themselves. So some extremely cool use cases. And a feature we just launched a few weeks ago is the ability to pull in multiple virtual cameras from a 3D world and render those all to the web browser all simultaneously, giving the user the control to switch in between different camera views. So think about this in a virtual concert. You're at Tomorrowland or at Coachella, and you want to get a quick preview of what's going on another stage. You can teleport in between these different stages, and you can enable these environments directly from the workflows that we're discussing. But what is another missing element is the ability to pull in professional video. How can you bring your toys, your professional encoders? We can ingest RTMP, but the best thing about all of this is doing it with a native WebRTC workflow. So we partnered with Osprey Video, and they've created a WebRTC WIP integration. And WIP is just a standard signaling protocol to deliver broadcast quality media using WebRTC, right? And so that all encoders can quickly and easily connect with services like Dolby.io and others in the industry. So this now allows you to render to a big virtual screen inside of Unreal Engine a 4K or 1080p HDR quality stream directly inside of Unreal. So that's another missing piece of being able to bring your traditional encoders and professional cameras into these 3D worlds. And with that, that's my presentation. Hopefully I was on time, but if you have any questions, post them here in the chat.
Yeah, we definitely have time to take some questions, Ryan. So yeah, put them in the chat or in the Q&A. Looking at that Metaverse example, it's amazing to see how things have progressed just in the last 2 years. I remember at the beginning of the pandemic, when we were scrambling to find virtual solutions for our streaming media conferences. We tested out a couple of those immersive environments, and not Metaverse, but at the time it was nothing that we would have considered using. Looking at this, if cost isn't a consideration, of course, yeah, this is terrific. And you're right about the the business and healthcare and education use cases being, even though we all lead and and the concert stuff is the sexy stuff, right? We're going to see increasingly that businesses, healthcare, education are going to be implementing VR and the metaverse to get things done. What are you seeing? Where are you seeing most of the interest come from? Is it still coming from media and entertainment?
I do believe, that they're the people that the content creators push the boundaries of what can be done, and big brands follow suit after that, right? So it always takes a while for very large brands like the NFL or broadcasters themselves to jump on board. What I'm seeing is a lot of very original technology developers who are partnering with big brands like Universal. There was a premiere on Netflix, and the actual movie was produced by Universal, I believe. And it was the J-Lo movie that came out with Owen Wilson back in February. And Oz did a virtual live concert with J-Lo and Maluma to launch that event. And they did it through this whole integration with Snapchat. So is Snapchat developing it? No. Is Universal doing it? No. But Oz was that technology provider that was smart enough to get in bed with a couple of large production companies to enable these workflows. So the vendors are out there. And to your point, I think cost is a consideration when you consider running a individual virtual machine for every person connecting to a virtual concert. The costs get extremely high extremely quickly. But what you're seeing happen in the industry through companies like Xilinx that just got bought by AMD and NVIDIA and a lot of the hardware FPGA manufacturers and so on, starting to see custom built machines directly for game engine rendering. And that's going to bring the cost a lot further down than using general purpose machines with AWS and other cloud vendors.
Excellent. And now we do have some questions in the Q&A. The first one is, will WebRTC service ever get quicker than the minimum I experience now, which is about 400 milliseconds?
Yeah, I mean, I want to speak generically, not do too much of a sales pitch about it, but WebRTC, I mean, on our platform, depending on when you are in the world, like I'm in San Francisco, I can get 50 milliseconds round trip because we have a data center. Now that's over the public cloud, but going into an ingest point that's here in SFO. But we are seeing consistently, I would say an average of about 200 to 300 milliseconds through most of the Western world, I would say, through most of our data centers. I think as we continue to build out our CDN, we own our own architecture and we're spinning up new data centers. Seems like every month now, we have Amsterdam, we have Singapore, and we have plans to do more. It's going to bring the latency further and further down because you do less public hops across the public internet. I think ultimately the big difference between low latency HLS or modified MPEG-Dash or CMAF stuff that's happening in the traditional streaming space is those are all TCP protocols that if you have buffering issues, it's going to sit and pause because you need to deliver all the packets. WebRTC doesn't work that way. It works over UDP, so it will drop packets if it needs to, and latency is prioritized. So it's the right technology, I truly believe, for a lot of these real-time use cases.
Yeah, and the last question is, with all of this, it still looks 2D on a human face. Any thoughts on 360-degree cameras and such getting integrated to make humans look actually 3D, or maybe even multiple camera views to render a 3D human avatar?
Yeah, great question. So I was just working with a customer of ours who works in the remote post-production space, and we were talking about the idea of doing stereo video, where you can actually render left eye, right eye, and create a more believable experience. Now that's on the playback side. On the render side inside, I haven't seen anyone play with face recognition and multi-point, kind of like you do with CGI, when you get human bodies in motion and so on and can map them to a 3D layer. That technology is there, it's just not there in the metaverse yet. However, the 360 space, we do honor, we have a 360 player with our Millicast player, or Dolby IO real-time streaming player. And we can capture real-time 360 content, either through OBS or natively through some of those 360 cameras. What nobody's done yet is render that 360 into a 3D sphere, let's say, inside of an avatar in the metaverse. So I wouldn't be surprised if you see a lot of evolution happen there and it'd be a little bit more believable than it is now.
All right. Well, thanks so much, Ryan. And thanks to Dolby for sponsoring this session.